Good day everyone, especially to our instructor, Sir Razel Montenegro Gumanoy. Good day, sir. Today we're going to discuss the chapter 7, which is measures of central tendency and dispersion or variability. So here are the learning outcomes. First is explain the meaning and function of the measures of central tendency and measures of dispersion or variability. Second is distinguish among the measures of central tendency and measures of variability or dispersion. Then lastly is explain the meaning of normal and skewed score distribution. A measures of central tendency is a single value that attempts to describe a set of data, like scores, by identifying the central position within that set of data or scores. As such, measures of central tendency are sometimes called measures of central location. Central tendency refers to the center of a distribution of observations. Where do scores tend to congregate? In a test of 100 items, where are most of the scores? Do they tend to group around the mean score of 50 or 80? There are three measures central tendency: the mean, the median, and the mode. Perhaps you are most familiar with the mean, often called the average, but there are two other measures of central tendency, namely the median and the mode. Is there such a thing as best measures of central tendency? If the measures of central tendency indicate where scores congregate, the measures of variability indicate how spread out a group of scores is, or how varied the scores are, or how far they are from the mean. Common measures of dispersion or variability are range, interquartile range, variance, and standard deviation. So now I'm going to discuss the measures of central tendency. The mean, mode, and median are valid measures of central tendency, but under different conditions. One measure becomes more appropriate than the others. For example, if the scores are extremely high and extremely low, the median is a better measures of central tendency since mean is affected by extremely high and extremely low scores. So what are the three measures of central tendency? So the three measures of central tendency are the mean, median, and the mode. What is mean? The mean or average or arithmetic mean is the most popular and most well-known measure of central tendency. The mean is equal to the sum of all the values in the data set divided by the number of values in the data set. When not to use the mean? The mean has one main disadvantage. It is particularly susceptible to the influence of outliers. These are values that are unusual compared to the rest of the dataset by being especially small or large in numerical value. For example, consider the scores of 10 grade 12 students in a 100-item statistic test below. The mean score for these 10 grade 12 students is 62. However, inspecting the raw data suggests that this mean score may not be the best way to accurately reflect the score of the typical grade 12 students, as most students have scores in the 5 to 95 range. The mean is being skewed by the extremely low and extremely high scores. Therefore, in this situation, we would like to have a better measure of central tendency. As we will find out later, taking the median would be a better measure of central tendency in this situation. What is median? The median is the middle score for a set of score arranged from lowest to highest. The mean is less affected by extremely low and extremely high scores. So how we find median? Suppose we have the following data: 65, 55, 89, 56, 35, 14, 56, 55, 87, 45, and 92. To determine the median, first is we have to rearrange the scores into orders of magnitude, from smallest to largest. like this: 14, 35, 45, 55, 55, 56, 56, 65, 87, 89, and 92. So our median in this is the score at the middle of the distribution. In this case, 56 is the middle score. So our median is 56. There are 5 scores before it and 5 scores after it. This works fine when you have an odd number of the scores, but what happens when you have an even numbers of the scores? What if you had 10 scores like the score below? 65, 55, 89, 56, 35, 14, 56, 55, 87, and 45. So first, you have to arrange the data according to order of magnitude, smallest to largest, in order to get the middle scores. So like this: 14, 35, 45, 55, 55, 56, 56, 65, 87, and 89. Then take the middle scores, 55 and 56, and compute the average of the two scores in order to get the median. So in computing the two middle scores in order to get the median is first you have to add the two middle scores, the 55 plus 56. So 55 plus 56 is equal to 111. Once you get the sum, next is you will have to divide the 111 into 2. So 111 divided 2 is equal to 55.5. So your median is 55.5. What is mode? The mode is the most frequent score in our dataset. On the histogram or bar chart, it represents the higher bar. If it is a score of the number of times an option is chosen in a multiple choice test, you can therefore sometimes consider the mode as being the most popular option. Study the score distribution below: 14, 35, 45, 55, 55, 56, 56, 65, 87, and 89. So in this score distribution, we can see that the most frequent score is 55 and 56. So we have a score distribution with two modes, hence a bimodal distribution. Next is I will discuss the normal and skewed distribution. A score distribution sample has a normal distribution when most of the values are aggregated around the mean, and the number of values decreases as you move below or above the mean. The bar graph of frequencies of a normal distributed sample will look like a bell curve. If mean is equal to the median and median is equal to the mode, the score distribution shows a perfectly normal distribution, and it is illustrated by the perfect bell shape or normal curve shown in this figure 13. If mean is less than the median and the mode, the score distribution is a negatively skewed distribution. See in this figure 14, you can see that in a negatively skewed distribution, the score tend to congregate at the upper end of the score distribution. Then, if the mean is greater than the median and the mode, the score distribution will be a positively skewed distribution. See in this figure 15, in a positively skewed distribution, you will see that the score tend to congregate at the lower end of the score distribution. So next, I will discuss the outcome-based teaching, learning, and score distribution. If teacher teach in accordance with the principle of outcome-based teaching, learning, and so align content and assessment with the intended learning outcome, and reteach till mastery what has or have not been understood as revealed by the formative assessment process, then student score and the assessment pace of the lesson will tend to congregate on the higher end of the score distribution. Score distribution will be positively skewed.
Good day, everyone. My name is Janice Ramirez Vertudaso. My topic is all about measure of dispersion or variability. If the measures of the central tendency indicate where score congregate, the measures of variability indicate how spread out a group of scores is or how varied the scores are. Common measures of dispersion or variability are range, variance, and standard deviation. What is variability? Variability refers to how spread out a group of scores is. The terms variability, spread, and dispersions are synonyms and refers to how spread out a distribution is. Range, variance, and standard deviations are the three common measures of dispersion or variability. Now, the first one is range. What is range? So the range is the most simple of variety. The range is simple, the highest score minus the lowest score. Here are the examples. Let's take a few examples. What is range of the following group of the scores? 10, 2, 5, 6, 7, 3, and 4. The highest number is number 10, and the lowest number is 2. So 10 minus 2 is equal to 8. So the 8 will be the range. The second one is variance. Variability can also be defined in terms of how close the scores in distribution are to the middle of distribution. Using the mean as measure of the middle of the distribution, the variance is defined as the average square difference of the scores from the mean. The third one is standard deviation. The standard deviations measure the spread of the data about the mean value. It is useful in comparing sets of data which may have the same mean but a different range. To calculate the standard deviations of those numbers, there are four how to calculate standard deviation. Number one is work out the mean, simple average of the numbers. Number two is then for each number, subtract the mean and square the result. Number three, then work out the mean of those squared differences. Number four, take a square root of that and we are done. So if those are the way of how to calculate the standard deviation. One thing that is important to notice is that mean deviations where mean is 0. This will always be the case. The mean of the square deviation is 1.5. Therefore, the variance is 1.5. Here are the formula and the how to solve standard deviation.
I am Carl K. Gemelo Valenzuela. 7.5 comparing. When we use the whole population, we got mean equals 7 standard. Division equals 2.983. When we use the sample, we got sample mean 6.5. Standard deviation equals 3.619. Our sample mean was wrong by 7% and our sample standard deviation was wrong by 21%. Why we take a sample? Mostly because it's easier and cheaper. Imagine you want to know what the whole university thinks. You can ask thousands of people. So instead you ask maybe only 300 people. Samuel Johnson said, "You don't have to eat the whole ox to know that the meat is tough." 7.6 More notes on standard deviation. The standard deviation is simple, the square root of the variance. The standard deviation is an especially useful measure for the variability when the distribution is normal or approximately normal because the proposition of the distribution with a given number of standard deviation from the mean can be calculated. For example, 68% of the distribution is within one standard deviation of the mean, and approximately 95% of the distribution is within two standard deviation of the mean. Therefore, if you had a normal distribution, a mean of 50, and a standard deviation of 10, then 68% of the distribution would be between 50 minus 10 equals 40 and 50 plus 10 equals 60. Similarly, about 95% of the distribution would be between 50 minus 2 times 10 equals 30 and 50 plus 2 times 10 equals 70. The symbol of the Popular-Stern standard deviation is 0. Figure 2 shows two normal distribution. The distribution has a mean of 40 and a standard deviation of 5. The other distribution has a mean of 60 and a standard deviation of 10. For the distribution, 68% of the distribution is between 35 and 45. On the other distribution, 68% is between 50 and 70. Figure 18. Normal distribution with standard deviation of 5 and 10. A standard deviation is a measure of dispersion. The more depressed the data, the less consistent the data are. The lower standard deviation means that the data are more clustered around the mean, and hence the data set is more consistent. An example is standard deviation for a data set with frequency 1 using the following data: 10, 15, 13, 25, 22, 53, and 47. We found that the mean to be x equals 26.4285,714. You should also see from the same calculation that the standard deviation equals 16.98879,182. Let us use the standard deviation to compare two datasets. Let us use the standard deviation to interpret how consistent the data are. The lower the standard deviation, the more consistent the data are. 7.7 Interpretation of standard deviation. Let us use the standard deviation to compare two datasets. Let us use the standard deviation to interpret how consistent the data are. The lower the standard deviation, the more consistent the data are. Example: two boilers, Katie and Mike, have the scores given below. Katie's scores are 189, 146, 200, 241, and 231. While Mike's scores are 235, 201, 217, 168, and 186. Both sets of data have a mean equals 201.4. Does this mean they are equivalent boilers? No. Consider the standard deviation. Katie has a standard deviation of 37.6470 and Mike has the standard of deviation of 26.1017.